This report on the Saturn V launch vehicle, the vehicle which will provide the power to establish and maintain this country's clear superiority in space, covers the period from December 1st, 1966 through February 28, 1967. The Saturn V is the free world's largest launch vehicle. It was started in January 1962 when NASA authorized Marshall Space Flight Center to design and develop a very large and powerful launch vehicle. The Saturn V is designed to place in Earth orbit a payload of 250,000 pounds, or send a 98,000-pound payload to the Moon. It stands 365 feet high, weighs, when fueled, 3,100 tons, and consists of 3 propulsive stages and an instrument unit. Development of the Saturn V first stage is being accomplished by MSFC and the prime contractor, the Boeing Company. The first successful acceptance test of a flight stage was performed at MSFC in February of 1966. The stage is a cylindrical booster 33 feet in diameter and 138 feet in height. The stage is powered by 5 F-1 engines built by Rocketdyne Division of North American Aviation, and generates a total of 7,610,000 pounds of thrust. The F-1 engines utilize liquid oxygen and RP-1 kerosene as propellants. The stage has a dry weight of about 300,000 pounds and a propellant capacity of 4,400,000 pounds of liquid oxygen and RP-1. The second Saturn V stage is designed and manufactured by the Space and Information Systems Division of North American Aviation. It measures 33 feet in diameter and is 81 feet tall. Initial acceptance testing of the first flight stage was performed in November 1966 at the Mississippi Test Facility. The second stage is powered by 5 Rocketdyne J2 liquid oxygen, liquid hydrogen engines with a continued combined thrust of 1,025,000 pounds. Early second stage flights will carry 930,000 pounds of supercold propellant. The third stage prime contractor is Douglas Aircraft Company, and the first flight stage was acceptance tested in May 1966. The third stage is 22 feet in diameter, stands 59 feet tall, and is propelled by a single Rocketdyne J2 engine. Engine propellants are liquid oxygen and liquid hydrogen that burn for a thrust of 225,000 pounds. The Saturn V third stage has engine restart capability, which will be used for Earth orbit escape and to establish a lunar trajectory. The instrument unit, which contains the astronomic equipment that guides and controls the Saturn V, was developed by MSFC and is manufactured by IBM. The instrument unit is 22 feet in diameter and 3 feet high, and consists of 6 basic systems: structural, telemetry, radio frequency, guidance, control, and electrical. The first Saturn V flight vehicle was erected at Kennedy Space Center last quarter, except for the second stage. A simulator substituted for the actual stage, which was still undergoing acceptance testing at the Mississippi Test Facility. The second stage arrived at KSC in January, after successful completion of acceptance tests. The upper portion of the Saturn V flight vehicle was de-erected in mid-February in order to permit removal of the second stage simulator and its replacement with the actual stage. Use of the simulator had allowed checkout of the available stages and ground support equipment before arrival of the second stage. The third stage and instrument unit were installed, and the first Saturn V flight launch vehicle stood fully erected on February 24th, culminating over 6 years of research and development, manufacturing, and ground testing. Rollout to Pad A is due in late June. Meanwhile, high bay checkout operations, including vehicle electrical mating, swing arm tests, and flight simulation tests, will be performed in preparation for launch in mid-1967. At the Marshall Space Flight Center, stacking of the Saturn V dynamic test vehicle was completed early this quarter, with addition of the instrument unit, spacecraft adapter, and Apollo spacecraft. This artist concept illustrates how the Saturn V dynamic test vehicle appears when fully erected inside the dynamic test stand. Configuration 1, or full vehicle testing, began after completion of stacking. The vehicle was vibrated by electrodynamic shakers to determine the bending and vibration characteristics the vehicle will be subjected to during flight. This bending and vibration data is required to verify the adequacy of guidance and control systems design. Several minor irregularities indicating the need for possible engineering changes were discovered as a result of Configuration 1 testing during this period, and additional tests in these areas will be conducted next quarter. Configuration 2 testing, which includes testing the entire vehicle, minus the first stage, will then begin. The purpose of this test series is to verify guidance and control design for conditions which will be encountered after first stage separation. Post-static firing modification and checkout of the second flight stage continued at the Marshall Center. The stage is scheduled for shipment to KSC early next quarter. Third flight stage post-static checkout and refurbishment, such as the replacement of static testing heat shields, were performed during the quarter by the prime contractor, Boeing, at Marshall's Michoud Assembly Facility at New Orleans. The stage had been successfully static tested at Marshall during the last report period. Delivery of the stage to KSC is due in the latter part of next quarter. Following completion of post-manufacturing checkout of the fourth flight stage at Michoud late last quarter, the stage was removed from the stage test building and returned to the manufacturing plant for incorporation of modifications and storage until shipment to the Mississippi Test Facility for acceptance testing next quarter. Horizontal installation work on the fifth flight stage was completed early this report period, and the stage was transferred to the stage test building for post-manufacturing checkout. The stage will be shipped to MTF next quarter. Vertical assembly of the sixth flight stage has been finished, and horizontal installation is in progress, with completion due next quarter. The seventh flight stage is now undergoing vertical assembly, expected to be finished late next quarter. Structural assembly of major components, such as this lower fuel bulkhead, for the 8th and 9th flight stages is underway, and minor fabrication work such as milling of bulkhead gore segments continued. The first flight stage, which had undergone initial acceptance testing at MTF during the last report period, completed the test series by being successfully static fired for the second time on December 30th. The firing was for a full duration of 364 seconds, with engine cut off by LOX depletion. The pressurization system performed satisfactorily, and programmed engine gimbaling was successful. The stage was shipped in mid-quarter to KSC, where post-static checkout was completed, and the stage was installed as part of the first Saturn V flight vehicle. Modifications and engineering changes not incorporated into the stage at MTF will be completed prior to launch at KSC. Due to problems encountered with the first flight stage, the second flight stage was held for modification and rework at the Seal Beach facility of North American Aviation's Space and Information Systems Division. These modifications were completed late this quarter, and the stage was delivered to the Mississippi Test Facility. Here the stage was installed in the A2 static test stand, where the first acceptance test will be performed next quarter. Upon completion of a second acceptance firing, the stage will then be shipped to KSC. The third flight stage liquid hydrogen tank forward bulkhead, damaged last quarter by a falling ladder, has been replaced with the bulkhead originally scheduled for use on the fifth flight stage. Systems installation, underway when the bulkhead accident occurred, is now nearly finished, and systems checkout will begin shortly. The stage is expected to be shipped to MTF late next quarter for acceptance testing. Vertical assembly operations on flight stages number 4 and 5 have been accomplished, and systems installation is underway. The 6th flight stage is in the process of vertical assembly, with completion due late next quarter. In the continuing component test program, a common bulkhead test tank was subjected to an ultimate pressure test at the contractor's Santa Susana facility. The liquid hydrogen tank portion of the test article was under 38.4 psi hydrostatic pressure when the anticipated failure occurred. This is a slow motion sequence on the destruct test. The common bulkhead and liquid oxygen portion of the test article remained intact. The hydrogen tank portion was removed from the test stand, and some sections were taken to the metallurgy laboratory at S&ID's Downey, California plant for detailed study and analysis. Post-static firing checkout and modification work on the 2nd flight stage were completed on schedule at the Douglas Aircraft Company Sacramento test site, and the stage was delivered to KSC. The terminal countdown for acceptance firing of the 3rd flight stage was begun on January 20th in Beta 3 test stand. 11 seconds before simulated launch vehicle liftoff was reached, and with all systems showing normal operation, the stage exploded and was completely destroyed. No personnel were injured. Damage to the test stand was substantial, but is repairable. An investigating board composed of Marshal and DAC personnel determined that the explosion was caused by the complete failure of one of the titanium high-pressure helium spheres mounted on the thrust structure. The sphere failed because of weld deficiencies due to the wrong type of filler wire being used during pressure sphere welding. Marshal has taken appropriate steps to ensure that a similar situation will not occur again. In addition, all titanium spheres presently assigned to the Saturn V and uprated Saturn I programs are undergoing reinspection and testing to assure they meet all specifications. Under a schedule recovery plan, the 4th flight stage has been substituted for the damaged 3rd flight stage, and all subsequent stages through the 6th flight stage have been moved up and redesignated. A new 6th flight stage will be inserted into the manufacturing schedule. The new 3rd flight stage was shipped from the Douglas Huntington Beach facility to the Sacramento test site late last quarter and installed in Beta 1 test stand. Acceptance firing is scheduled for next quarter, 3 weeks later than the original schedule. Structural assembly operations were completed on the 5th flight stage at Huntington Beach, and systems checkout is in progress, with completion scheduled in April. Structural fabrication continues on the 6th and 7th flight stages. 7 F-1 engines were delivered this quarter by the prime contractor Rocketdyne. Instrumented to allow study of vibration levels, one of the engines was used to further substantiate the feasibility of cross-country truck transportation for F-1s instead of air transportation. The truck-transported engine arrived at the Marshall Center in excellent condition after its 2-week trip from the Rocketdyne Canoga Park, California plant. A total of 56 F-1 engines have now been delivered to NASA, including those for the first 7 Saturn V flight vehicles. Rocketdyne's J-2 engine component qualification test program, which began in April 1965, is now virtually complete. Components such as this main oxidizer valve were tested during this report period. Only one of the 36 items selected for the component test program remains to be tested. This will be accomplished early next quarter. Rocketdyne's new J-2 component installer assembly device, designed for use on Saturn V 2nd and 3rd stages when in a stacked position, underwent testing this quarter. The device can be used to install or remove all components of the J-2 engine except the thrust chamber after the engine has been installed in a stage. At the Air Force Arnold Engineering Development Center at Tullahoma, Tennessee, a total of 18 J-2 engine environmental restart verification tests were conducted this quarter. The tests simulated conditions such as orbit coast time and thermal environment of the first Saturn V flight vehicle during flight. Tests for the initial flight vehicle will be completed next quarter. Work on the second Saturn V flight instrument unit continued on schedule during the report period by the prime contractor IBM at its Huntsville facility. After installation of modification kits and partial retest, the second flight IU will be delivered to KSC early next quarter. Assembly operations on the third flight IU were completed early this quarter, and checkout is in progress. Checkout operations were interrupted in mid-February because of the partial retest of the second flight IU. Completion of checkout and shipment to KSC is expected during the next report period. Structural fabrication of the fourth flight IU has been finished, and component assembly is in process, with completion due next quarter. At Marshall's Mississippi Test Facility, construction activity is nearly complete. Early in the quarter, a test first stage was placed in the first stage test stand to prove the operational readiness of the stand. Stage, ground support equipment, and facility systems checkout have been completed, and the first firing is slated for early next quarter. The stand is scheduled to be completely operational by the middle of the year. With second stage static firings already underway and first stage firings about to begin, with construction virtually complete and test site facilities, including data processing, propellant handling, laboratories, and shops fully operational, the Mississippi Test Facility has started to assume its full role as a major resource in this nation's space program. In summary, despite the explosion and loss this quarter of a third stage due to helium sphere weld deficiencies, major milestones in the overall Saturn V program were achieved during the report period, with the first Saturn V flight vehicle now fully erected and pre-launch checkout operations underway. Full vehicle dynamic testing nearing completion, and final acceptance testing of the initial flight's second stage at the almost fully activated Mississippi Test Facility.